Part 4. The Art of Influence, Human Dynamics, and Decision-Making.
Shifting gears again to the people side.
Yeah, because in software engineering, let's be honest, the best technical solution doesn't always win. Success often hinges on your ability to communicate effectively, to persuade stakeholders, negotiate trade-offs, build strong relationships.
Technical skills get you in the door, influence skills get things done.
Exactly. And as AI potentially handles more routine technical tasks, these so-called soft skills, they're rapidly becoming hard requirements for leadership and impact. Our first book in this section is by a former FBI hostage negotiator, Chris Voss. Never Split the Difference. Negotiating as if your life depended on it.
Such a great title and a fascinating read.
His premise is that negotiation is a deeply emotional process, not just a logical one. And he offers these psychologically grounded techniques to build rapport and influence outcomes.
And it's quite surprising, maybe, how universally applicable these skills are for the software engineers. You don't think of engineers as negotiators, but you are constantly.
Really? How so?
You're negotiating feature scope with product managers all the time. You're negotiating technical designs and approaches with your peers. You're negotiating deadlines and resources with management. It's nonstop.
Sure.
Voss's core method, what he calls tactical empathy, is about understanding your counterpart's mindset, their perspective, their underlying emotions, in order to gain trust. It's not about agreeing, it's about understanding. His calibrated questions, those open-ended how and what questions, are brilliant because they essentially make the other person solve your problem for you. They shift the dynamic from confrontation to collaborative problem solving. Questions like, how am I supposed to do that?
Puts the ball in their court.
Exactly. And even simple techniques like mirroring, just repeating the last few words someone says or labeling their emotions. It seems like you're concerned about the performance implications here, can de-escalate tension and build rapport surprisingly quickly.
But some might dismiss these as, manipulative tricks only for high-stakes hostage situations, or maybe think AI will handle negotiation simulations soon. What's your counter-argument there?
Well, the goal is absolutely not to trick people. It's genuinely about making them feel heard and understood. That builds trust, which allows you to arrive at better solutions for both sides. It's collaborative. And the AI will handle this idea. It's completely irrelevant here. Negotiation is a fundamentally human interaction based on emotions, psychology, nonverbal cues. An AI cannot read the frustration in a product manager's voice over Zoom. It can't build genuine, long-term working relationships based on trust.
So how does this play out in a typical engineering scenario?
Okay, picture a daily technical design debate. Two senior engineers are completely deadlocked on different approaches, maybe getting heated. A third engineer, acting as a facilitator, can use Voss's techniques. They might use labeling. Okay, it seems like you're very concerned about the long-term scalability if we go with option A and to the other person. And it sounds like you feel option B offers much better immediate performance.
Acknowledging both views.
Right. Then maybe mirroring. If someone says option A is just too complex, the facilitator mirrors, too complex, encouraging them to elaborate beyond the label. Then, calibrated questions. How could we mitigate the scalability risks effectively if we decided to proceed with option B? Or what would need to be true for option A to feel simple enough? This shifts the focus from winning the argument to collaboratively solving the underlying concerns.
That's powerful.
Even when you're prompting an AI, you can use calibrated questions. What are the most memory-efficient ways you know to sort this data? And can you provide an example that clearly illustrates the trade-offs involved? Get the AI to work for you.
It really drives home that technical skill alone isn't enough to advance your career. The ability to negotiate, persuade, influence that separates a senior engineer from a true technical leader.
Big time.
And as AI automates more routine coding, the value of these human-centric skills just increases. You can use them to drive technical decisions, secure better projects, maybe even better compensation, and excel in leadership roles. It's about mastering conflict, de-escalation, trust building, guiding teams toward common goals.
It gives you a durable competitive advantage that's immune to automation. People skills matter.
Next, Robert Cialdini's Influence. Psychology of Persuasion, another classic, this one on social psychology.
Yeah, Cialdini's work is foundational for understanding why people say yes.
It explores what he calls the weapons of automatic influence, these 6 universal principles like reciprocity, social proof, authority, liking, scarcity, commitment, consistency, which act as mental shortcuts in our decision-making.
And for a software engineer whose effectiveness relies so heavily on collaboration and teamwork, this book is absolutely essential reading. These principles are constantly at play, whether you realize it or not.
Where do you see them?
In code reviews, definitely. In design meetings. In presentations to leadership or other teams. Understanding these principles leads to far more effective communication and, well, influence.
Okay, give an example.
All right, when you're arguing for a particular technology choice, showing that it's a widely adopted industry standard, that many respected companies use it, that's leveraging social proof. It's incredibly powerful because people feel safer doing what others are doing.
Makes sense.
Establishing yourself as a credible expert on a topic, maybe through past successes or clear explanations, that builds authority, making others more likely to accept your recommendations. Getting agreement on a small initial principle first, we all agree we need a reliable system, right? Makes it easier to gain commitment for a larger action later, using commitment and consistency.
Now, a common criticism here is that it teaches manipulation. And again, some might think AI will make these human persuasion skills obsolete. Maybe AI bots will do the persuading.
Well, while the principles can certainly be used unethically, and Cialdini warns against that, his primary goal is actually to educate you so you can recognize when these tactics are being used on you and resist unwanted influence.
Defense as well as offense.
Exactly. For engineers, it's about framing your sound technical arguments compellingly and ethically, not faking expertise or tricking people. And the AI will make this obsolete argument. It holds no water whatsoever. These principles are deeply wired into human psychology. AI doesn't change the fact that humans are influenced by social proof or feel obligated by reciprocity.
If anything, AI might make understanding human psychology even more important.
I completely agree. As AI handles more analytical tasks, the truly human skills like empathy, persuasion, communication, relationship building, those become the primary differentiators. An AI can analyze code, but it cannot mentor a junior engineer through a tough problem, resolve interpersonal conflict between teammates, or inspire a team to rally around a difficult goal.
So how would you apply these principles, say, when advocating for a major code refactor? That's often a hard sell.
It is. Okay, you'd want to layer the principles. You'd use authority by presenting clear data on current bug rates, maintenance costs, maybe developer frustration levels. You'd leverage social proof by citing examples of other successful companies in your space who benefited from similar refactoring efforts. Maybe use reciprocity by offering a small, useful, automated tool first, something that helps with the piece of the problem, building goodwill.
Right.
Use commitment and consistency by getting everyone to agree on a shared value upfront. We all agree that our long-term goal is a reliable, maintainable, and efficient system, correct. Then show how the refactor supports that shared goal. You might even use scarcity by framing the decision in terms of a closing window of opportunity. If we don't tackle this technical debt now, it's only going to become exponentially harder and more expensive later.
Technical excellence is foundational, clearly. But the ability to influence is the accelerator for your career and impact.
It really is.
As AI automates more the coding, the value shifts to the how.
Yeah.
How do you get your good ideas implemented? How do you get buy-in?
Right.
Mastering these principles allows you to lead effectively, even without formal authority.
Yeah.
To be a more impactful tech lead or architect. To navigate organizational politics constructively. Ultimately, just to get more important stuff done.
It's about understanding and interacting with people, a deeply human capability that powerfully complements technical expertise.
Our next selection is maybe a bit unexpected. The most important thing, illuminated. Uncommon Sense for the Thoughtful Investor by Howard Marks. It's an investment philosophy book.
Yeah, not a typical software engineering read, but incredibly valuable.
It's not about magic formulas or stock tips. It's about disciplined thought processes, emphasizing what he calls second-level thinking, understanding the difference between price and intrinsic value, and the paramount importance of controlling risk.
And what makes this book so surprisingly relevant is its direct application to making strategic technology decisions. The tech industry, and especially the AI space right now, is just characterized by intense hype cycles, FOMO, and significant uncertainty.
Totally. It's hard to see clearly sometimes.
Marx's principles cut through that noise beautifully. His most critical concept, second-level thinking, is about moving beyond simplistic surface-level views. First-level thinking says, AI is the future. Invest everywhere. Use the biggest model.
The obvious conclusion.
Right. Second level thinking asks, okay, everyone knows AI is the future, so that optimism is already priced into the hype, the valuations, the competition for talent. What are the less obvious second-order effects of this trend? What risks are being ignored by the crowd? Which contrarian bet that goes against the grain might be overlooked but holds real potential?
It's deep.
That is the very essence of strategic technical leadership, thinking beyond the immediate hype.
Now, the most obvious misconception here is this is a book about stocks. It's not relevant to me as an engineer. But that feels like a classic case of first-level thinking itself, doesn't it?
You've hit the nail on the head. It is a failure of first-level thinking to dismiss it like that. The book is about a philosophy for making high-stakes decisions under uncertainty in complex, dynamic systems. The stock market is just his primary domain, for example. The principles are universal.
And can AI really make these better decisions that Marx talks about? Does it do second-level thinking?
That's a great question. And Mark's work really challenges the narrative that AI will just make better decisions across the board. AI, especially current AI, struggles with qualitative, nuanced, second-level thinking. It struggles to assess things like long-term strategic vision or market psychology, or predicting non-consensus outcomes that depend on complex human factors.
Okay, so how does an engineer apply this thinking day to day? Maybe choosing a foundation model for a new AI product.
Perfect example. First-level thinking says, use the biggest, most famous, most capable foundation model because, well, everyone else is, and it's the best.
Right. Follow the herd.
But applying second-level thinking, you'd ask, okay, everyone's rushing to the biggest models. That means the costs are high, the competition for specialized expertise is fierce, maybe vendor lock-in is a bigger risk. What if a smaller, maybe open-source model is actually good enough for our specific application? It might have a much lower price in terms of cost, latency, ease of deployment, for potentially much better overall value for us.
Finding the inefficiency.
Exactly. Perhaps the real differentiator isn't the raw model size, but our ability to fine-tune a smaller model effectively on our unique proprietary data. That could be a contrarian bet. You'd also explicitly consider risk control, like avoiding vendor lock-in, maybe prototyping multiple options using different models, a portfolio approach, just as Marx advocates for investing.
Internalizing this philosophy really elevates you from just a technical implementer to a strategic thinker. That feels like a crucial leap for anyone aspiring to roles like CTO or VP of engineering.
It's a mandatory leap at that level.
You can navigate the inevitable hype cycles in the AI industry with more rationality, more skepticism. Make superior technology bets by focusing on the underlying value and risks, not just the surface buzz. Become a source of uncommon sense within your organization, challenging conventional wisdom constructively.
Yeah, being the voice of reason.
This is a form of wisdom of judgment that AI currently cannot automate, making it an invaluable, enduring asset for your career.
Deeply valuable.
Okay, finally in this section, we have perhaps the foundational text on interpersonal skills. Dale Carnegie's How to Win Friends and Influence People, first published way back in 1936.
The OG of people skills books still sells millions.
It really does. It provides these timeless principles for interacting effectively with others, rooted in things like showing genuine interest, avoiding criticism, and making others feel important.
And this raises an important question. Why is a book from 1936 still so crucial, maybe even more crucial in the AI era?
Yeah, why? Seems counterintuitive.
Because software engineering is fundamentally a collaborative team sport. Technical skills are only half the equation, maybe less than half sometimes. Your ability to work effectively with other people is what translates your technical prowess into actual results and impact. Principles like don't criticize, condemn, or complain. That's the golden rule for giving constructive code review feedback, right? Make it about the code, not the person.
Absolutely.
The only way to get the best of an argument is to avoid it. That's crucial for navigating technical debates constructively. It encourages you to genuinely try to see things from the other person's perspective before pushing your own. And the basics, building rapport through showing genuine interest in others, smiling, remembering names, these are timeless building blocks for trust within any team.
But some people criticize its advice as being common sense or maybe even manipulative flattery. And the ultimate misguided narrative I sometimes hear is that AI will make soft skills obsolete. What do you make of that?
Well, the book truly emphasizes sincerity. It's not about fake flattery. It's about making a genuine effort to understand, appreciate, and connect with others. The reason some of it seems like common sense is because it is foundational, but it's common sense that's surprisingly uncommon in practice, especially in high pressure, sometimes ego-driven technical environments.
True enough, we forget the basics.
And the AI will make soft skills obsolete narrative. That is perhaps the most misguided of all. As AI continues to automate more analytical and routine tasks, the deeply human skills like empathy, communication, collaboration, relationship building, influencing, they become the primary differentiators. They become more valuable, not less.
Yeah.
And AI can analyze code metrics, sure, but it cannot effectively mentor a junior engineer through their first big project crisis. It cannot resolve a brewing conflict between two team members. It cannot inspire a team to overcome a seemingly insurmountable challenge. That takes human connection.
So how can you weave Carnegie's principles into daily engineering work?
Okay, let's say a product manager proposes a feature that seems technically infeasible, maybe with a ridiculously tight deadline. Instead of starting with, no, that's impossible, you begin in a friendly way, talking in terms of their interests. Wow, I can see how this feature would be a huge win for our users. That's exciting.
Start positive.
Be a good listener first. Ask them to walk you through their vision, their goals for it. Then, maybe the most powerful principle. Try honestly to see things from the other person's point of view and let the other person feel the idea is theirs. So instead of directly saying your timeline is impossible, you ask collaborative questions that lead them towards that conclusion. Okay, given that we need to build a completely new data pipeline first to support this, which parts of the feature are the absolute most critical to deliver by the deadline so we can show valuable progress to the users?
Guiding them to the reality.
Exactly. It's much more effective. This book is a career accelerant, plain and simple. Technical skills get you in the door, but people skills are what enable you to lead projects, influence technical direction, build consensus, and advance into senior leadership roles.
Absolutely.
In an AI-driven industry, strong interpersonal skills make you a more effective collaborator, a better mentor, a leader who can bridge that crucial gap with non-technical stakeholders. As one engineer famously noted, the people skills are what makes someone shine. This book provides the foundational training for those essential differentiating human skills. It's the operating system for effective teamwork.